In this example, what we have here is a proportion with 3 parts on each side of the equal sign. So we've got a 2 to 5 to 6 ratio equal to a 3 to x to y ratio. There's a couple of methods to go ahead and try to use to solve this proportion, to try and solve for the unknowns, and we'll take a look at method A here. Method A has us inspect portions of each side of this proportion. In the first case, we're taking a look at this 2 to 5 ratio, and we're going to compare it on the other side of the equal sign to the 3 to x ratio. Again, you can see that the order here is very important. Second way that we're going to solve in this method is by taking a look at the next ratios. So we've got a 2 to 6 ratio on this side, and we're going to compare that to the 3 to y ratio on the other side. And lastly, we've got a 5 to 6 ratio compared to an x to y ratio. Again, taking each part and each pair on both sides of the proportion. Now what we have are 3 smaller parts that we can go ahead and try and use to solve for each of the unknown variables. Taking a look at the first one here, we've got a 2 over 5 equals 3 over x proportion. To solve this, what we need to do is perform the cross-multiplying procedure, which has us multiply the 2 times the x, then the 5 times the 3, looking something like this. 2 times x is 2x, and 5 times 3 is 15. To solve for x, we need to divide by 2 on both sides, looking something like this, giving you x equals 7.5. Next one we're going to take a look at is to solve for y, and we'll use that same procedure of cross-multiplying. So we'll do 2 times y and 6 times the 3. 2 times y is 2y, 6 times 3 is 18. Again, we need to divide by this number in front of y to isolate it. So we'll divide by 2, giving you y equals 9. So we've solved for x, we've solved for y, and we're not going to use this third part because it had 2 unknowns, x and y, in this second fraction here. Can't use that one. We need to take a look at the ones where we have only one variable so that we can use the procedure of cross-multiply to be able to solve for our unknowns. The second method that we can use when solving these proportions, when we have 3 parts on each side, is to compare the 2 numbers in the appropriate spots on each side of the proportion, on each side of the equal sign. So we've got a fraction here, 2 to 3, and we'll compare that 2 to 3 to the next place value, or the next portion of the proportion, which is a 5 to x ratio. So we're going across the equal sign with these ones. So a 2 to 3 ratio is going to be equal to the 5 to x ratio, which is also going to be equal to the last part of a 6 to y ratio. Again, we're going across the equal sign, looking at the pairs of numbers and the ratios of numbers that can be created in this format. We can split this proportion up and these ratios up so that we can solve for the unknown variables. And the first part is taking the 2 over 3 equal to the 5 over x. And like in method A, we're going to cross-multiply here to be able to solve for the unknown value. 2 times x is 2x, 3 times 5 is 15. To get the x all by itself, we'll divide both sides by 2, giving you x equals 7.5. You can see that it's the same result that we had before, slightly different method. To solve for y, we'll use that 2 over 3 fraction again, and we'll use this 6 over y, and we'll compare those 2 fractions or ratios. 2 times y when we cross multiply is 2y, 6 times 3 is 18. To get the y all by itself, again you need to divide by 2, giving you y equals 9. Same result as we had before. One method has you looking on each side of the equal sign each side of the proportion, setting up your ratios and proportions accordingly. The other one has you going across the equal sign. Both will give you the correct results.